Newton's second law of motion mathematically states the cause and effect relationship between force and changes in motion. Force is equal to mass times acceleration, and we can use the equation to calculate what happens in situations involving a force. The force applied to an object is directly proportional to its mass and the acceleration it experiences as a result of that force. An object with more mass will experience less acceleration when the same force is applied to an object with less mass. Newton's second law describes resulting changes in motion due to the application of an external force. Acceleration is a change in velocity, making it a change in motion. If an external force causes a change in motion, then a net external force causes acceleration. Acceleration is directly proportional to and in the same direction as the external force acting on the system. Mass can be defined as how much matter an object contains, and as a result, how heavy it is. Acceleration is inversely proportional to the mass of a system. When mass is larger, acceleration is smaller. An external force is defined as a force that acts from outside the object or groups of objects. The object or group of objects the force acts on is called a system. An internal force acts between the objects contained within a system, but only external forces affect the motion of a system. Net force is the total force acting on an object when all individual forces are combined. It's the vector sum of all the forces applied to an object, considering both magnitude and direction. If multiple forces are acting on an object in different directions, the net force is calculated by adding up the forces that act in the same direction and subtracting those that act in the opposite direction. If two forces of 10 newtons are pushing an object in the same direction, the net force would be 20 newtons. However, if one force of 10 newtons is pushing in one direction and another force of 5 newtons is pushing in the opposite direction, the net force would be 5 newtons in the direction of the larger force. The net force determines the object's acceleration according to Newton's second law, which is force equals mass times acceleration. And friction is the force that opposes motion as objects slide across each other, and its opposition is considered in calculating the net force. The Newton is used to measure force, once it's calculated, and it's defined as the force needed to accelerate 1 kilogram at a rate of 1 meters per second squared. The net force on a falling object is the gravitational force called weight. Weight is a vector quantity that moves in the same direction as gravity, and the symbol for weight is W. Weight is equal to mass times gravity. If the only force acting on an object is its weight, that is to say, the net external force on an object is its weight, we say that object is in free fall. Weight in physics is defined as the gravitational force acting on an object from the nearest large body. Weight is equal to the mass of an object multiplied by the gravitational acceleration of the nearest large body. In physics, mass and weight are different quantities, and the terms are not used interchangeably. Mass is the quantity of matter contained in an object and does not vary, while weight can vary as gravitational acceleration varies. When we describe how much weight an object has in everyday language, to describe how heavy an object is, what we're actually describing is its mass. A few questions for discussion purposes. How do you think the relationship between force, mass, and acceleration helps engineers design safer vehicles, like cars or airplanes? And what are some examples where friction is beneficial and others where it's harmful?